Dr. Paige Stanely has a background in biology, animal husbandry, and environmental science. She combines all of these disciplines to study grazing management and how carbon sequestration works in rangelands.
To me, it's not enough to just do the research. It's really important to me to get that information back to the ranchers and make it relevant in their context, and to do research that is relevant to them.
Years ago, Paige set out to measure carbon sequestration on various ranches in California and quickly realized much more research was needed into how to sample and analyze and properly quantify baseline soil organic carbon and changes to that carbon over time.
But I think that's one of my primary concerns as a scientist, is knowing what it actually costs to actually do this correctly and within a small margin of error is more expensive than the profit that somebody is making off of, a single carbon offset. Then that should raise questions in folks. Well, how are they making it profitable? If doing it accurately is more expensive than it would be worth, what is changing to make it profitable for them? And often that means taking much fewer samples and selling much more uncertain offsets.
Dr. Paige Stanely joins the show to talk about the challenges of measuring carbon sequestration, the role livestock play in that process, and her outlook for the future of regenerative agriculture. Well, hello, fellow Agner. Thank you so much for joining me for another episode of The Future of Agriculture. My name is Tim Hamrich, and every week you and I get to hear from the founders, farmers, innovators, and investors, the people shaping the future of the ag industry. In today's episode, and really every episode this quarter, is brought to you by the Soy Checkoff. It takes more than hard work to move a commodity. It takes a strategic plan and farmer leaders like you to implement it. And that's your Soy Checkoff. Whether it's finding new markets for oil and meal, investing in production research to help get more from every acre, working with the supply chain to impact your bottom line, having a sound plan delivers results. And you and your fellow soybean farmers are proving it through your Soy Checkoff. See all the ways the Soy Checkoff is moving soy forward for you at unitedsoybean.org. And thank you very much to the Soy Checkoff for supporting ag innovation and the Future of Agriculture podcast. All right, back to today's episode with Dr. Paige Stanely. Paige is an interdisciplinary scientist working to understand how grazing management can sequester carbon in soils to help mitigate climate change and build more resilient rangeland ecosystems. She draws on a wide range of disciplines, including soil biogeochemistry, grazing and rangeland ecology, agroecology, rancher sociology, and political ecology to approach research questions holistically. And I think you're going to get a good sense of what all of those words mean in this conversation, because we cover quite a bit of that. Paige is particularly interested in the use of regenerative grazing, also known as adaptive multi-paddock grazing by ranchers on rangelands, a form of high-intensity, short-duration grazing with the potential for increasing soil carbon sequestration through those practices. All right, I know we hit a lot of buzzwords there, but stick with me, because this really is a fascinating and wide-ranging conversation about regenerative agriculture, for lack of a better catch-all term. But within that, we really hit a lot of interesting points, from the challenges of carbon measurement to grazing management to carbon-nitrogen ratio dynamics to producer economics to rancher sociology and beyond. Really a lot of fun to talk to Paige again, which reminds me, this is the second time that she's been on the show. Her first appearance happened about 3 years ago in September of 2020. That was back on episode 222. Actually happens to be one of my favorites. If you want to go back and listen to an episode I particularly enjoyed, you can go back. It's titled Digging Deeper into Regenerative Agriculture. I'll link that in the show notes as well. You don't need that episode for this one. I think they kind of work well in tandem, but you can listen to this one first and then go back, or whatever you want to do. It's your podcast player. You do whatever you want. Anyway, we're going to kick off today's episode with Paige recapping what led her into the long process of understanding what it takes to properly sample, analyze, and measure soil carbon sequestration. And I think this is really, really, really relevant given the current discussion that seems to take for granted how difficult this can be to get it right with a high level of accuracy. So here it is, my second interview with Dr. Paige Stanely.
So early on in my dissertation, as I was thinking about, I mentioned that I'm interested in grazing management and soil carbon. I'm like, okay, how can I tease apart some of these questions and this like kind of truncated time frame that is a PhD. So I was, designing this experiment where I was going to be measuring soil carbon outcomes from grazing management in California. And as I'm writing a grant to be able to do these things, in your budget, you need to budget for how many samples you're going to take. And that will project how much money you need for sampling and analytical costs and things. And I was like, okay, well, how many samples do I need to take? And that question turned into like a 3+ year long journey to try and answer it. And my advisor at the time, Dr. Tim Bowles, who's incredible at Berkeley, he encouraged me to just get out and do some reconnaissance sampling. So just like go out on one of the ranches you're going to be working on, take some preliminary samples, and let's see how variable they are. And that'll help us figure out, how to move forward. So I did, alongside a friend and colleague of mine, Jessica Chiartis, who did her PhD at UC Davis, but more on the cropland side. She and I went out to a ranch that we had connections with in California. And the original plan was just to take maybe like a couple of samples, maybe a couple dozen samples. We wound up being out there for 5 days and collecting 800 soil samples from this ranch. And I think just the more we were out there, the more we were boots on the ground and looking at the landscape. It was rocky, the topography was variable. California rangelands specifically are kind of these oak woodland mosaics. So there was variability from top to bottom in just about every way you could imagine. So anyway, we collected all of these samples, and then our kind of questions started to expand from there. And we wound up roping in a statistician at UC Berkeley, Jake Spertus, who was co-author on the paper that we wound up publishing, to help us with some of the more statistical questions. But it wound up being us trying to answer questions about variability in California rangelands and croplands, and trying to understand what it actually takes to measure soil organic carbon and then measure soil organic carbon change. So just quantifying a baseline carbon stock within a degree of accuracy, that question is actually very different than trying to detect and then quantify very small changes over time. So the first is like, you're trying to get an accurate measurement of this really large pool, whereas the second question is kind of like trying to find a needle in a haystack. You need to be able to first detect that change, so the change in soil carbon from time 1 to time 2, and you also need to be able to accurately quantify it if that's your goal. So you need to be able to say, like, we sequestered 0.5 ton of carbon per hectare per year over the last 5 years or something like that. And that is a much harder challenge. So that's kind of how the question got started and how it grew. And we wound up publishing this manuscript that I'm really proud of, but wound up taking us a lot longer than I anticipated. But it started a lot of conversations, I think, specifically within the carbon market space. Scientists, I think, have known for a while, but maybe it was one of those like red herrings that we just didn't really want to talk about because it's expensive. It would require us to take a lot more samples than we're used to taking. So I think it's gotten conversations started on both ends, but the ramifications, I think, are a lot larger for the carbon market space.
Yeah, huge ramifications. And before we maybe go there, or in an effort to get there eventually, I guess, how accurate can we get when measuring soil organic carbon, given, all that work that you just did?
I mean, you can get as accurate as you want, depending on your budget. If you have an unlimited pocket and you can dig deep, you can take, hundreds or possibly thousands of samples, and the limit doesn't exist, essentially. You're always going to have some degree of uncertainty, but you can narrow it pretty good if you're willing and able to take a ton of samples. More commonly, what people try to do is base the number of samples they take on a given budget. And so they'll kind of start from the top and figure out their way down. But in reality, it needs to be the reverse if we actually want to be able to quantify those changes accurately. And so you need to figure out, first, how many samples do you need? Second, how much is that going to cost? And then third, is that feasible? And if not, then maybe we need to think about a different question.
Yeah. So if I'm a carbon market company, I'm trying to sell carbon credits or carbon offsets, and I hear all this, I'm thinking, oh man, this sounds more expensive than the carbon is worth in the market. Is that the problem we're running into?
That's exactly the problem that we're running into. It's less of a problem on croplands than it is on grass and rangelands. Croplands tend to be more homogeneous, basically because usually it's a single type of thing or forage or plant or crop grown on it. Usually it's tilled. So everything that we do to croplands tends to homogenize the soil. Whereas on grass and rangelands, these things aren't plowed unless it's a pasture, and they're typically not irrigated. And, to what I was saying earlier, they're often grass and rangelands and not croplands for a reason. Whether that's rocks or low and patchy soil fertility, grazing adds another level of heterogeneity in there. And so the costs and I think challenges to quantifying soil carbon change on these two different landscapes are different. And that's why I think we've seen most of the carbon market space centering on croplands, although now you're seeing them migrate into grasslands more or trying to. But I think that's one of my primary concerns as a scientist is knowing what it actually costs or likely costs to actually do this correctly and within a small margin of error is more expensive than the profit that somebody is making off of, a single carbon offset. Then that should raise questions in folks. Well, how are they making it profitable? If doing it accurately is more expensive than it would be worth, what is changing to make it profitable for them? And often that means taking much fewer samples and selling much more uncertain offsets.
Okay, yeah. And on your first interview on the show here, we talked a lot about like what exactly is happening when carbon is being sequestered. Is it's being trapped down there? It's being trapped in different ways. What exactly are we doing when we're sequestering carbon? So I highly recommend everybody go back and listen to that episode as well. So I'll try not to just repeat, although I find that conversation very interesting. But I would like to know, a lot of your work has been done in grasslands. And these, I imagine, are perennial grasses and very good for carbon sequestration because we're not kind of tilling up the land and letting, those gases back out. But I do wonder what role the livestock play in that system. Are they just basically the living tractors that are managing these perennials that are really doing the hard work of sequestering carbon? Or is there something else to the science of maybe the microbial interaction between something coming off of the livestock and going into the crop? Like what exactly is their role? Or are they just, living mowers, for lack of a better term?
Yeah, Tim, this is a great question. It's actually really timely because myself and Francesca and some colleagues, Megan Mockmiller and Chris Wilson, are all writing a manuscript about this right now. And actually, a lot of the work that I did, most of the work that I did during my PhD was on annual grasslands. So California grasslands are kind of non-native annuals for the most part. And so just to add a little nugget that we've still got a lot of work to do in understanding the opportunity of soil carbon sequestration with grazing on different types of vegetated grasslands. So like annuals versus perennials, C3 versus C4. This is still a little bit of a question mark, though we can kind of conceptualize what those are. But to your question, what exactly are livestock doing to help us sequester carbon when they're grazing? There's a couple of different things that they do, but if you think about it at its most basic level, what often I think people think of is that livestock are just removing biomass. So how can biomass removal help us do anything to sequester carbon, right? Because you think of sequestering carbon, you want more inputs, more biomass going into the ground. And cattle are obviously removing some of it to grow their own bodies, respiring some of it in the form of methane, et cetera, et cetera. So if you think of the grass growing on a landscape, really most plants have a really high C to N ratio. So that means there's a lot of carbon per unit nitrogen. And what we know about soil carbon sequestration now is that there are different fractions of soil carbon that behave really differently. They have different lifespans in the soil. They have different ways of getting there. And it turns out that lower C to N ratio inputs. So these are things like legumes with a lot of nitrogen or really green grass, for example, fresh new things. Manure is low C to N. Those tend to contribute to a fraction of soil carbon called MAM, mineral associated organic matter. And that's a more persistent, stabilized fraction of soil carbon that tends to stick around for much longer. And so it's not just an inputs-outputs equation in the way that we think about soil carbon formation anymore. And so livestock, in a couple of ways, can contribute. Specifically, what we're measuring is increases in that MAM, that more persistent, more stable fraction. So by removing biomass, for example, during the grazing process, they're masticating, they're ruminating on some of it, and they're pooping. And that manure tends to be a really high quality soil input, likely more high quality than the plant itself when it's on the surface. So it's kind of transforming plant biomass into something that's easier for microbes in the soil to use and makes them more efficient at forming that pool of stable soil carbon. So that's one way. The other way is in timing of grazing. So, if you imagine a grassland that's growing grass and no grazing happens, no biomass is removed. Eventually, throughout the year, those plants will senesce. So they'll turn brown, they'll seed out. That's when you see the C to N ratio really skyrocket. And it's really hard for that plant material, once it's senesced and kind of woody and tough, to become stable organic matter. It's really hard for microbes to use. It's just like tough cardboard. By removing some of that biomass early on in the grazing season, you can kind of keep plants in the vegetative phase for a little bit longer. And so that maintains their life cycle and it extends the carbon inputs into the soil at a lower C to N ratio for longer. So that's another way. We are actually attempting to answer the question about the role of microbes with livestock grazing in soil carbon sequestration, soil carbon turnover. That is something that I'm really excited about, but we don't have good answers to yet. I'm actually submitting a grant in a few weeks with Kelly Wrighton, who is a microbial ecologist here at CSU and who has done a lot of like ruminant microbial community work. So hopefully we'll get at some of that. And so I think some of these mechanisms are really clear on how livestock can help increase soil carbon. But then there are still remaining questions about different ways of management and the direct mechanisms by which they're causing these changes. So, grazing can happen in a lot of different ways. Animals can be left in big pastures to kind of graze throughout the year with little to no rotation. And a grazing system like that will have very different impacts than one, a management system where animals are moved really frequently, potentially where some pasture rest is incorporated. But exactly those mechanisms are still unclear to us. And that's not because we've been unable to answer them, but I think we've just not done a good job at measuring those things. And I have this big kind of stick to wield with the history of grazing soil carbon research and problems in the literature, but we can get into that later if you want.
Oh, okay. Well, no, is that a whole other episode, or is that something you could sum up for us?
It could be both, but let me try to sum it up. I'll try to sum it up briefly and concisely. So there's a couple of problems historically when scientists have tried to measure soil carbon change with grazing management, grazing in general. One is to that spatial heterogeneity point. So if you look back in the literature, often people just aren't collecting enough samples. And so I don't have a ton of faith in some of these papers that are, saying grazing might have no impact. I think that might be true, but we don't know based on some of those papers, based on the number of samples they took. Second is that a lot of historical literature is just looking at grazing versus no grazing, which doesn't really tell us a lot. I think about these nuances that we know exist in grazing. Just the presence of grazing animals tells us nothing, considering that grazing management exists along this huge spectrum. And then lastly, what I see most commonly is a lot of grazing studies will conflate things like grazing intensity with things like stocking rate. So just thinking that the number of animals equates to grazing intensity over the landscape, which we know is not true because it changes with things like, movement and rest and timing and duration. Anyway, so I think the literature is just not very strong.
Okay, so there's so much to dig into there. I do want to go back to the fractions of, carbon that's being sequestered. First and foremost, so the C to N ratio, does that have to do with what types of microbes are active in those conditions, or does it just have to do with the chemistry of like there's less carbon kind of in that? I'm trying to understand the impact of the C to N ratio on like carbon sequestration.
Yeah. So if you think about all the things that contribute to soil carbon, right? It's above ground biomass, it's root matter, it's things that roots are exchanging with things in the soil, like root exudates. It's microbial necromass, or like microbes once they die and decay in the soil. So there's a lot of different things that can enter the soil and contribute to soil carbon. Some of those things have a lot of nitrogen. For example, microbes have a really low C to N ratio. There are different types of plants. So legumes, for example, things like alfalfa or clover that have natural nitrogen fixing capabilities. So that will, lower their C to N ratio. That's really important because microbes are most efficient. So microbial necromass, kind of dead microbes, are one of the main contributors to that stable soil organic carbon fraction. But in order for microbes to be able to use a substrate to grow their bodies, to grow their communities, to build in microbial biomass, they need nitrogen. And so they'll kind of eat away at the carbon in things until they get to the nitrogen. And the more carbon there is per unit nitrogen, the lower the carbon use efficiency in those microbes are, and the more of that carbon is actually respired instead of sequestered. And so that's just one aspect of soil carbon sequestration, but generally speaking, higher C to N ratio soil inputs lead to more of that carbon being respired than sequestered than is the case in lower C to N ratio things.
Yeah, the way I often visualize things, and this is going to be very unscientific and very nuanced, but it maybe will get us a general level set and then we can continue the conversation is, okay, so forever, we have cycled carbon through topsoil, through growing crops, and even in natural systems. We've got this carbon cycle that's always going through topsoil. And granted, we've probably changed the way that cycle is gone through tillage, through more intensive agriculture. But then at the same time, over here, we've got this like deep stored carbon in fossil fuels that we have been mining and burning at unsustainable rates. So I think the question that often I get from the ag community is like, look, we're kind of cycling this carbon like we've always cycled this carbon. And granted, we're using a lot of these fossil fuels. So maybe the answer is like, more on the fossil fuel side. Is there really anything we can do in this kind of what I'll call like a shallow carbon cycle in the topsoil to actually more permanently be part of the solution? And I know that's a little bit convoluted of a way of saying that, but I think from the ag community, it's kind of like, are we really going to sequester any carbon that's going to come close to offsetting all of these fossil fuels that we've been burning?
Yeah, that's a great question. Certainly I nor many of my colleagues think that soil carbon sequestration is the silver bullet answer to get us out of this like fossil fuel dilemma that we have. We know, and I think it's important to acknowledge that fossil fuel burning and use is the primary contributor to climate change and anthropogenic greenhouse gas emissions. And yet, I think we can simultaneously acknowledge that while reducing the use of fossil fuels is the primary way to mitigate climate change, we don't have enough time to not consider the addition of other options. And that's where I think soil carbon sequestration plays an important role. So it's something that we think of as a natural climate solution. You're right, ag has been involved in this carbon cycle for a really long time. Even basic landscapes, cycle carbon through their soils and through this plant-soil atmosphere interface. But I think it's an important opportunity because I don't remember the latest numbers. It's somewhere like a third of our total natural climate solution opportunity is in soil carbon. So it's not enough to get us a get out of jail free card when it comes to fossil fuels, but it's enough to help add another layer of buffer into what we're doing. Because we know that to meet our climate goals of staying under 2 degrees warming, we can't just stop burning fossil fuels. We need to be actively drawing carbon dioxide out of the atmosphere. Like that's the time that we're in right now, the type of time crunch that we're facing. And I also think it's easy to sell this soil carbon sequestration opportunity because it comes with so many co-benefits. And there are even some soil scientists who don't even like to talk about soil carbon in terms of climate change mitigation because they think these other benefits are so much more paramount and important. For example, soil carbon is such an important contributor to soil fertility. It drives a lot of soil processes that are important to agriculture. And so in terms of just like farm economics, profitability, lowering inputs, which are often fossil fuel derived, things like fertilizer, electricity necessary for irrigation, these things go hand in hand. And so, I think it just depends on your audience, who you're talking to. If it's going to be something like climate change, getting them on board with thinking about soil carbon sequestration, then absolutely, I think that's valid. If it's something like soil health and reducing their input costs in order to increase their profitability, I think absolutely that's also valid. But I think it's important to put in perspective the role of soil carbon sequestration in terms of climate change mitigation. It's necessary, but insufficient on its own.
Perfect. That is exactly the sort of like context I wanted to have kind of for this next question, which is kind of, based on all these years of research you've been doing on this, I imagine you remain optimistic about our ability to really fill that 1/3 role that you mentioned of, soil carbon being a way to sequester carbon. I'm just curious, related to that, what do you believe about the potential here that maybe the science hasn't proven yet, but, is something that you do either hope for or at least believe yourself?
I mean, in terms of regenerative agriculture, which is, seems to be what's getting a lot of hype right now in terms of like how we face agriculture and really hunker down on sequestering carbon, which is my jam. Like that is my research jam, regenerative grazing, soil carbon. At the same time, I see a lot of people talking about things like nutrient density and healthier food coming out of these systems. That's one area where I feel like the evidence is really lacking. Not to say that it's not true, but maybe I'm not sold. I'm not convinced quite yet. Alternatively, I think one thing that I really think, and this is going to be an unpopular opinion, I think that often I hear pushback on like, oh, well, what's the point of sequestering carbon or like investing all these resources into soil carbon sequestration if it's going to saturate? Like if we're going to cap out on it sometime soon. I think saturation is important to talk about. At the same time, it's kind of this hypothetical limit. And I don't think that it needs to hinder us from seizing this opportunity for soil carbon sequestration because we have such a deficit in where our agricultural soils are now and this theoretical limit, max capacity that they can hold in terms of soil carbon. So I don't deny that saturation can exist in some hypothetical terms. I also don't think that it's a realistic max that we're going to need to worry about anytime soon. So that might be my hottest take. I'm sure I have more, but I'd have to think about it.
No, that's good. And I'm curious about, how you see the path forward. I mean, obviously your work is fundamental and I hope it continues, for a very long time, the research you're doing, but zooming out a little bit to like what needs to happen for us to really tap into this opportunity to sequester more carbon in soil. What do you see as the big milestones that might move the needle?
Yeah, this is a good one. People conceptualize change in different ways. I think a lot about my research and its impact on actually making change. And what does that look like? To me, it's not enough to just do the research. I have been at, 3 land grants now. It's really important to me to get that information back to the ranchers and make it relevant in their context and to do research that is relevant to them. But I think, in terms of change, when it comes to specifically grazing and soil carbon, what are the levers at our disposal to take what we're finding out in the science realm and leverage that in terms of ranchers changing their practices to things that we're learning that, increase soil carbon or, what does that look like? And I think there are a couple of different camps. One is the kind of consumer-facing, bottom-up way. And that would be things like, can we convey the value of, this beef and the way it was managed and its impact on soil carbon in terms of a label and get people to pay some sort of premium with the understanding that that premium would then incentivize more people to do it because they can see that their product is selling for more. That's one way. And, we've seen that in terms of like the USDA organic label, which is the only, codified kind of into policy, into law, sustainability label that we have. I tend to be skeptical of that because I think to rely on the concerted actions of, in the US, 330 million people to do something in terms of climate seems unlikely. And also, I think that we've kind of reached market saturation in terms of our labeling scheme. So I think every additional label feels a little bit like white noise. Like, what does this actually mean? If you talk to consumers about what they think the labels mean, it's often not what it actually means. And in terms of what they actually are willing to spend their money on, often they say these things are important, things like sustainability or all natural, organic or whatever. And yet often at the counter, they don't choose to buy those things. So that is kind of wraps up why I don't put a lot of weight in that lever, though I don't think that it's unimportant. It's just not where I tend to spend most of my time. To see some of these changes, I put a lot of weight into the policy realm, and that comes with its own set of trade-offs, right? We know policy is slow and inefficient and all the things that we know is wrong with it. At the same time, I think there are some really shining examples that show us why policy is really important, because it can create big sweeping change. So if we think in terms of, for example, California, they have used a lot of their cap and trade dollars to do things like the California Healthy Soils Program. And they've started to invest in grant dollars for a lot of these farmers and ranchers to create some of these changes. Right now we already have conservation programs built into the Farm Bill, which comes up every 5 years. So that's a really concrete example of ways that we can, get what we want into policy every 5 years on a recurring basis. And so I think there are, in terms of policy, important opportunities to, number one, peel back things that we know are causing barriers to farmers and ranchers from using these practices that we know can be really impactful for soil carbon. Things like on the cropland side, diversifying their agricultural production or reducing the level of inputs. And then there are also levers that we can pull to incentivize people to use these practices. There's pay for practice, there's pay for outcomes, whatever the strategy. I think that it's still an important tool. And yet I've done quite a lot of social science with ranchers over the past, 7 or so years. And I think it's also important to acknowledge that not everybody is going to respond to a price incentive, to just being paid to do something, especially in terms of regenerative ranching or like these really complex agricultural systems where maybe we're thinking in terms of, diversified farming systems with low inputs, or regenerative grazing where they're adapting rest and rotation schedules to match the landscape. These things are above and beyond these like single a la carte practices. And in that case, I think we've got to think a little bit bigger than just paying somebody to do one thing, because we know it tends to be these stacking of practices that turns out to be really beneficial for soil carbon. So for example, stacking no-till and cover cropping, or with grazing, the combination of rest and rotation. And I think that's where we still have a lot of questions and gaps to fill. What is it going to take for folks to be interested in stuff like that? And I think, at least in my mind, I always come back to just farm profitability. There was a book I read a couple of years ago that has just stuck with me called Farm and Other F Words by Sarah Mock. And I think the thing that stuck with me about it is like the farms that have the most longevity are farms that find a way to be profitable. And so I think at the end of the day, we've got to find a way for these practices to be profitable. And that's partially risk mitigation. I think it's partially, like I said, removing some of these barriers. But that's, I think, like the next policy frontier that I'm interested in.
Yeah, that's really interesting. I was thinking about Sarah's book. That's why I laughed when you mentioned that earlier. Because I was thinking about that book as you were speaking. I also wonder, because I am always very focused on farm profitability. I think, that's, the lever of like, if you can make it the profitable thing, it'll get adopted. I wonder if that's any different in grasslands, though. You've studied grasslands. I wonder, though, like, it seems like there is a higher percentage of acreage, would be my guess, of people who want the acreage more than they necessarily want the cattle or the money. They buy land because they have money to buy land. Whereas, with row crop farming, if somebody's buying land, they're usually renting it out to a farmer that's actually kind of doing the practices. I don't know. Is that different with grasslands? And if so, does that even make your point all the more relevant that, like, it's not always about money?
Yeah, no, I think you hit the nail on the head. There's this whole history of literature in like the rancher sociology realm, where like early in the 70s, just as kind of these rich moguls were starting to buy up ranches in the US West. And we've seen this tradition continue up until now. Like these super rich people are buying up these huge ranches, and we're seeing this like changing of hands in a way that is not always in line with like our ag goals. Anyway, there's this whole literature of, rancher sociology where early in the 70s, economists started to ask, why aren't some of these ranchers selling their ranches when the profit they could make from the land is light years ahead of what they could ever expect to make off of being a rancher, selling beef, producing beef, or whatever. And I think the finding that emerged throughout the 70s and into the late 90s was that ranchers aren't just in it to make profit. And I think that's what makes their sociology and their barriers and incentives different than some of the other agricultural sectors. They're in it for other consumptive uses. They like the tradition. There's this rich history and culture of ranching in the US. They're in it for tradition. They're in it for the lifestyle. It's important for them to raise their families on these places where they grew up. The land itself is really important to them. And so they've been willing to kind of shave off other aspects in order to just maintain cohesive ranch units. So we've seen ranchers and farmers in general too taking off-farm jobs. So it's actually more rare now to find a rancher whose full-time job is ranching than it was many years ago. And they make all these sacrifices in terms of profitability, in terms of their own time, in terms of the amount of money that they could make from just selling the ranch and being done with it, because the ranching lifestyle is important to them. And I think that's really important to understand if we want to do something to make it profitable. And actually, this is a question that I posed in a manuscript I have in review right now, where I interviewed all of these ranchers using kind of more conventional and like way high on the adaptive end of the spectrum grazing management. And one thing that I gleaned out of that paper that I think is just so important is that in some ways, these adaptive ranchers have found ways of ranching that have allowed them to go from that traditional, work 40 hours a week at an off ranch job, come home, do this thing on the side. They found ways to ranch that have allowed them to not regress in terms of profitability, but go back to full-time ranching. And it's happened through a combination of things, like really concerted efforts to reduce their ranch input. So finding ways to reduce the amount of hay they need to buy every year, or thinking about their soil in terms of their primary natural resource base. Anyway, so I think there's no hard and fast answer there because people respond to different things. But I think that understanding these differences in culture is going to be the starting point to understanding how we get there.
Yeah, absolutely. Dr. Paige Stanely, thank you so much for being back on the show. This is really, this surpassed my expectations, even though they were set very high after your first appearance. Thank you. Anything else, though, you'd like to get on tape before I let you go?
Yeah, I might just throw out just a quick plug to the current project that I'm working on. It's called the 3M Project, Metrics, Monitoring, and Management. This is a huge $19 million research effort that's co-funded by USDA's FFAR and the Noble Research Foundation, along with some other private funders. Not to sound like a sales lady for this project, but I think it's the coolest, largest, most amazing project I've ever worked on in terms of the science. We're kind of spanning a bunch of different things. We're measuring things on grasslands and pastures. We're collaborating with all different types of scientists. We've got soil scientists like me and water folks, greenhouse gas flux folks, social scientists, economists. And I think for the first time ever, we're really going to have some really generalizable answers about, first of all, what is the opportunity to sequester carbon and improve ecosystem health with grazing management, but also link it back to things like social well-being and profitability. And we're measuring these things both at experimental sites to get at, some of this experimental control that's really important to scientists, and also across 60 farms and ranches across the US. So it's big in scope and in scale, and I think is such an amazing example of research collaboration between scientists and ranchers that I've ever seen. So you can Google it. We have a whole website. We'll be posting our data for the public on a big data visualization platform, so you guys can follow along. But just excited to talk to folks about that.
Well, I will certainly leave a link for that in the show notes, as well as a link to Paige's first appearance on the podcast and her website as well. So much interesting stuff. I just really enjoy speaking with Paige. I think she has this knack for bringing in this hard science, the deep scientific understanding of what's happening, with the context of how this needs to happen in real life on rangelands with ranchers and with farmers. And I just find so much value in her perspective and appreciate her being on the show again. Thank you very much to Paige. Thank you as well to the Soy Checkoff for being our quarterly presenting sponsor this quarter. And last but certainly not least, thank you for your time and your attention. I never take it lightly. I'll be back next week with another story of ag innovation.